Good evening, I'm Coach Robinson, and this is the 7th grade mathematical curriculum course. Today's lesson will be on prime factorization. In our last lesson, we covered prime and composite numbers, where we established the difference between the two. We know that prime numbers are numbers that only have two factors, meaning one in itself, and we know composite numbers are numbers that have factors that can evenly divide into a number without leaving a remainder. So just to give you a real quick example, a composite number, let's use the number 8. We know 2 times 4 equals 8. So 2 and 4 are factors of 8. Okay? And we know that the first set of prime numbers after the number 1 are numbers that don't have any factors. So that being 2, 3, 5, 7, 11. So these are the first 5 prime numbers. And again, prime numbers are numbers that only have factors of 1 in itself, okay? When you're doing a prime factorization problem, the objective is to list all of the prime numbers until there are no more factors. So again, let's use the number 8. Okay, we know factors of 8 is 2 times 4. And we know factors of 4 is 2 times 2. So we see here 3 prime numbers being 3 2s. So if they ask you the prime factorization of the number 8, the answer would be 2 times 2 times 2. Now, if you want to put that answer into exponential notation, you will count the number of 2's. So the answer will be 8 equals 2, representing the base prime number, and the exponent would be the number of 2's. So that would be 2 to the 3rd power equaling 8. This is how you put the answer in exponential notation. So now to get you guys more familiar with the concept, we're going to list all of the prime and composite numbers between 1 and 15. And for every composite number, we're going to list the prime factors of those numbers. So all of the prime numbers in blue and the composite numbers in green. So the number 1 is neither prime nor composite, so we won't list it. So we're going to go 2, 3, the number 4 is a composite number with the factors of 2 times 2. 5 is a prime number. 6 is a composite number with the factors being 3 times 2. 7 is a prime number. 8 is a composite number with factors being 2 times 4. 9 is a composite number with the factors being 3 times 3. The number 10 is a composite number as well, with the factors being 2 times 5. The number 11 is a prime number. The number 12 is a composite number, with the factors being 2 times 6. And the number 13 is a prime number. Excuse me. The number 14 is a composite number, with the factors being 2 times 7. And the number 15 is a composite number as well, with the factors being 3 times 5. Okay? Y'all see that? So those are the prime and composite numbers from 1 through 15, with the prime numbers being in blue and the composite numbers. On your assignment, you may see a problem that tells you to find the prime factorization for the number 24. All right, so let's write our 24 up here. Now you make a factor tree, okay? So you can start with any factors of 24, like numbers like 2, 3, 4, 6, and 8. and 12 are factors of 24. So let's go 8 times 3. Okay. So now we have one prime number already. We know 8 has factors 2 and 4. So break this down to 2 times 4. And now we know we have another prime number being 2. Now we have 4, which is a composite number, and that breaks down to 2 times 2. So the objective is to get all of the prime numbers without composite numbers. So the final answer will be 2 times 2 times 2 times 3 is the prime factorization for 24. Now, if you want to put this in exponential notation, you want to count the number of 2's. So now I have 3 2's. You want to put 2 as the base, and the number of 2's is the power. So that's 2 to the third power times 3. And that's the prime factorization and exponential notation of the number 24. No matter which factors you choose, I chose 8 and 3. If I do 12 and 2 or 6 and 4, you're still going to get to the same exact result. Okay? Make a factor tree for the number 36. Okay, so factors of 36. We know factors are numbers that can evenly divide into a number without leaving a remainder, or two numbers you can multiply to get the product of 36. So those numbers being 2, 3, 4, 9. Okay, so let's use the numbers 9 and 4. Okay, now we know we have two composite numbers because 9 and 4 both have factors. So we'll go 3 times 3 here and 2 times 2 here. So essentially the problem is done. If they ask you the prime factorization of 36, you will write 2 times 2 times 3 times 3. And if you want to put this in exponential notation, you could simply write 2 to the second power times 3 to the second power. And that'll give you your answer. 37th grade mathematical curriculum course. If you need a worksheet, any type of tutoring assistance of any magnitude, I can be reached at unityservice216@gmail.com, at unitytutors216 on Instagram. Thank you. Y'all have a blessed evening.